Welcome to our last section in Chapter 3, 3.5, 5-number summary and box plots. Here we're going to look at two things, two kinds of ways of summarizing data or looking at the data. The first is called the 5-number summary, and the second is called the box plot, which is a kind of a visual representation of the data. We explore data to see if it contains interesting information that may be useful in our research. The summaries we have studied make this exploration much easier. We're talking about the different data points. We figured out how to calculate the quartiles, central tendencies, etc. In fact, because these summaries represent an exploration, a famous statistician named John Tukey called this material exploratory data analysis. So let's look at the 5-number summary. The 5-number summary of a data set consists of data values that are either contained in the data set or calculations that we already know how to do. And so the 5-number summary is the minimum value of data in the data set, quartile 1, the median, quartile 3, and then the maximum value or the largest data value in the data set. Okay? And we simply organize it as a 5-number summary. So let's look at how we do this. The data shown in Table 17 shows the finishing time in minutes of the men in the 60 to 64-year-old age group in a 5K race. Determine the 5-number summary of the data. So the first thing we want to do is put the data in ascending order, okay? And we can see it here. Remember, the first value is the smallest number, which in this case would be the fastest time in the data set, and that's 1995. And it's really easy to find when we put it in ascending order. It's the first data point. The second point of this 5-number summary, the second number, is the first quartile. And this is the median of the lower half. Well, here we have the median. Well, there's 10 values in the lower half, so we have to find the mean of the two middle numbers, specifically the 5th and 6th data point that you see highlighted in yellow here, 25.83 and 26.28. And so we get a value of 26.06, which is the mean of those 2 points. The third point is the median. Since there's 21 data points, it's just the middle point, which is 30.95. The fourth number is the third quartile. And again, since we had 10, this is the median of the upper half of the data points. Since we have 10 above the median, we have to take them, again, the mean of the two middle points. Since it's an even number, we don't have a median specific data point in the upper half. And that mean gives us 37.24. And finally, the last number in the 5-number summary is the largest data point. And so we have the smallest number, 19.95, quartile 1, 26.06, the median, 30.95, quartile 3, which is 37.24, and the largest data point, which is 54.63. We can use technology to do this. You can use your calculator, you can use StatCrunch, etc. This is very easy, putting all the data in a column and then using stat summary. You do have to add the, I believe, quartile 1 and quartile 3 to that in order to get the median to come out, or to get those measures to be included in the normal StatCrunch data set. Here we're using Minitab, and you can see the 5 numbers to the right are indeed our 5-number summary. The next thing we're going to do is look how to visually represent some of the same data that we saw in the 5-number Summary. I don't know why number is such a hard word for me to pronunciate today. How do we draw and interpret box plots? Step 1. Determine the lower and upper fences. We saw this in the last section. Okay, remember that the lower fence is quartile 1 minus 1.5 IQR. The upper fence is quartile 3 plus 1.5 times IQR. And IQR, I think that's intermediate quartile range, is simply the range between quartile 1 and quartile 3. It's that middle range of data. So we get the IQR value by just taking quartile 3 minus quartile 1. Once we have this, we draw a number line that includes, it's got to be big enough to include the max and the minimum values in the data set. And we set vertical lines on that number line at quartile 1, the median M, and quartile 3. And then we enclose those vertical lines in a box. Don't worry, we're going to do an example so you'll see exactly how this works. Next, we need to label the upper and lower fences. We do this kind of like with a bracket or something at the box, beside the box, horizontally from the box that we just drew in step 2. Then we draw something called whiskers, and these are horizontal lines from, we draw a horizontal line from quartile 1 to the smallest data value that is larger than the lower fence. And we draw another line from quartile 3 to the largest data value that is smaller than the upper fence. Smaller than the upper, larger than the lower. Finally, we identify any outliers. Remember that any data values less than the lower fence or greater than the upper fence are called outliers. And on this number line, on this box plot, we mark them with an asterisk. So let's look at an example. Use the results from a previous example to construct a box plot of the finishing times of the men in the 60 to 64-year-old age group. I've included the data that we saw from Minitab just so we have those values so that we can build our box plot. Now remember, step 1 is to determine the upper and lower fences. IQR is quartile 3, 37.24, minus quartile 1, 26.06, which gives us 11.18. Okay, so the range between quartile 1 and quartile 3 is 11.18 minutes. That's the difference in time, finishing times of the men in this group from the first quartile to the third quartile. So our lower fence is quartile 1, 26.06 minus 1.5 times the IQR, which we just calculated as 11.18. So 26 minus 1.5 times 11.18 gives us 9.29. This is our lower fence. Our upper fence is quartile 3, 37.24 plus 1.5 IQR, which is 11.18. And doing that calculation, we get 54.01. Our next step is to draw a number line big enough to include the max and the minimum values. Our minimum value goes from 20 to a maximum value of 54.63. And so here we have a number line from 0 to 60. All right, from 0 to 60. Remember that we've got the number line, and then we're going to insert vertical lines at Q1. Q1 is 26.06. At the median, which is 30.95, and quartile 3, which is 37.24. And then we enclose those 3 lines in a box. That's a blue box that you see here. Quartile 1, median, quartile 3. Step 3 is to label the lower fence, which we calculated as 9.29, And the upper fence, you see just brackets here around the middle part of the box that we drew. The upper fence is 54.01. Okay. Now we draw lines that are called whiskers. Okay. So we draw a line from quartile 1 to the smallest data value that is larger than the lower fence. Our lower fence was 9.29. And our minimum data value is actually the smallest value that is larger than the fence, 19.95. We also draw a line from quartile 3 to the largest data value that is smaller than the upper fence. Our upper fence was 54.01, and the data point that is closest to that but smaller is 49.17, and you can see that line right here. So these are called the whiskers. They're coming off of, I guess that's the face of the cat, if you will. Our last point is to draw outliers, to identify outliers with asterisks. Remember, outliers are smaller than the lower fence. Any values that we would have, I don't know where my fences fell off there, and smaller and larger than the bigger fence. Okay, there is no values smaller than the smaller fence because 19.95 was our minimum value and our fence was 9. And we had one value data point that was larger than greater than the upper fence. Greater than the upper fence. And that was 54.63, which was our maximum value that we had. Okay. And so this is our box plot for the example that we just walked through. Okay. So let's look at how we can describe the distribution of our data using a box plot and quartiles. Here we have data that is skewed right, here we have data that is skewed left, and in the center we have symmetrical or bell-shaped curve data. And so notice that when it's skewed right, the whisker on the right is longer. When it's skewed left, the whisker on the left is longer. It's not skewed, it's longer. Okay. Typically as well, the median will be to the opposite direction since we're skewed left. Notice the median is further to the right inside the box. Here the median is further to the left in the shape that's skewed right. And then when we have a bell-shaped curve, the median's pretty much in the middle and the whiskers are roughly the same size. Okay, so based upon our last example, the box plot we just drew, we can see that the median is sort of to the left and the whisker to the right is longer. So we have a right skewed distribution of data. So now let's compare two distributions by using box plots. In the Space Lab Life Sciences 2, led by Paul Callahan, 14 male rats were sent to space. The red blood cell mass in millimeters of the rats was determined when they returned. A control group of 14 male rats was held under the same condition except for spaceflight as the space rats, and their blood cell mass was also measured when the space rats returned, which we can see in Table 18. The space flight rats are in white on the left, and the control group rats are on the right in the yellow. Flight is on the left in white. Control is on the right in yellow. I'm not sure I said that correctly the first time. So we want to construct side-by-side box plots for the red blood cell mass for the flight group and control group. Does it appear that the space flight affected the rat's red blood cell mass? So I encourage you to stop right here, hit pause, and calculate the two box plots. There's not a lot of data here. You can enter this in StatCrunch pretty quickly, or you can do it manually. It's not a hard data set to kind of calculate. When you've done that and you've looked at what do you think the space, done some inferences about, do you think the space flight affected the rat's red blood cell mass, then hit play again and we'll finish up. So the figure here shows the side-by-side box plots drawn in StatCrunch. Okay. What do you notice here? The top box is the control group, the bottom box is the flight group. Well, we can see that the median for the control group is greater than the median for the flight group. So the cell mass of the control group is larger than the cell mass central tendency of the flight group. So it would seem that spaceflight reduced the red blood cell mass comparatively to the control group. The spread as measured by the interquartile range appears to be similar, and that's this length of this, right, from quartile 1 to quartile 3. They do seem to be, about 1.5 units, and the same there. Okay. So this ends our discussion of Chapter 3.